So, hello everyone, I'm glad to see you again on my channel, and today we will see a very interesting exercise here because it's pretty different from what we have done before because here we need to create class and inner class, so it's a little bit different, but actually we will use same technique which we have done in the previous videos, so yeah. How this exercise is called, so it's time-based key value store. It's a medium level exercise, and let's check actually what we are given. So design a time-based key value data structure that can store multiple values for the same key at different timestamp and retrieve the key's value at a certain timestamp. And below, you can see that we need to implement two methods. It's a set method with three arguments, key value and timestamp, which need to store the key with value at the given timestamp. And the get method, it will return a value such that set was called previously with timestamp ref less or equal to timestamp. If there are multiple such values, it returns the one associated with the largest timestamp ref. If there are no values, it returns nothing, so empty string. And below you can see that we have an example, so you can check and better understand how does it work. So now let's answer to some questions. Let's check what kind of questions. So what is the challenge, why binary search, and what pattern we can use here. So what is the challenge? We need to store a history of values for each key. When searching, we aren't just looking for an exact match, we are looking for the greatest timestamp less than or equal to the target, also known as the floor value. Why binary search? The problem guarantees that timestamp is set operation are strictly increasing. This means the list of values for any given key is already sorted by time, making it perfect for all log n retrieval. And what pattern is suitable here? So binary search for the floor value. We search for the target, but we keep track of the last seen valid value, where timestamp is less or equal to target as we narrow down the range. So I hope these questions and answers help you better understand the task. So let's go and check how we can implement this algorithm in the code, and probably it will help you better understand actually how everything is working. So let's create first of all our um, map, because we will need a map in order to store a key, and value will be a class which aggregates, which combines, groups two parameters. It will be value and timestamp, but we will see it a little bit in the future. So now let's just create this map string, and we have here a list of, let's say, pairs, and we will call it map. How I already mentioned, pairs will be an inner class, but we will come to it a little bit later. So now let's just create a constructor, time base value store. Let's create a constructor here, and inside this constructor let's initialize our map. So new hash map. Perfect. And now let's create our inner class. Pair. which will group two variables. First will be our value and timestamp. Let it be of type int. You can use a timestamp actually here, but we have a little bit different condition. Yeah, so our timestamp will be just an integer, a number, 1 to 3 and so on. So we can use here just int, but not timestamp. But you can improve this task a little bit if you want. Timestamp. Okay, perfect. And let's create a constructor for this inner class pair. We will take two arguments, will be string value and int timestamp. And inside we will initialize these variables. Values will be equal to value and timestamp will be equal to timestamp. Okay, perfect. Now, if you remember, in the condition, we had two things to implement. So a method to set values and a method to get values. So first of all, let's implement the method which will set values inside our map. So public void, because it will not return anything, set. Okay, so we will take three arguments. It will be key, value, and timestamp. Okay, perfect. Let me remove this one because, oh no, actually no. Okay, perfect. Now let's first of all check. So put if present. So if we don't have, actually not, yeah, put if absent. So if this key is not present in our map, it means that we will need to initialize this list with pairs, because initially it will be equal to null. So we need somehow to initialize it, yeah, so to declare a list. And we can do it using this method from the Java, put if absent. So if this key is if it's absent, it means that we can initialize it doing like this. Perfect. And now let's get our key, and it will return us a list, and we will add in this list a new pair. And values will be this one, value and timestamp. Perfect. So that's the implementation for the set. Now let's implement get method, public string, because we want to return a value, and get. We will have here two arguments. First one will be a key, for which we want to return value, and timestamp. Okay, perfect. And now let's check if our map doesn't contains this key, then in that case let's return an empty string. But if it's present, it means that we need to take a list with our values and their timestamp. So let's do this list pair list, which is equal to map get key. Get key. So perfect. And now having this list with pairs, which means that we need somehow to use here binary search, and we need to let's implement it in a different method, and we will use this method to decide where to move on left or on the right depending on the timestamp. And how it was already mentioned, that timestamp is guaranteed to be in ascending order, so it's perfect for binary search algorithm. So so let's create our method, which we will use public string binary search. Okay, and here we will send our list of pairs and the timestamp. All right, now let's declare here a result variable where we will store the results. Okay, and let's declare left and right variables because we will need them in order to initially point to the first element and to last element, and also to calculate the middle element. So let's do this. Int left is equal to 0, int right is equal to list length size -1. Okay, perfect. And now, because we want to iterate through our list, we need to create a while loop, yeah, not for loop, because we don't know how much time we will need to iterate. So a perfect solution here is to use while. So till left is less or equal to right. Perfect. And now let's calculate the middle index for the middle element, which we will compare with our timestamp, with our target, if in our words. So it will be equal to left plus right minus left divided by 2. Okay, perfect. And now we will need to store somewhere the current timestamp middle, yes? So the timestamp from the middle pair. So current timestamp middle. Okay, and let's take this value from list dot get oops, here I have done a mistake, not left but list dot get middle, and from this pair, because it will return us not timestamp but object of the pair class, we need to take it timestamp. Okay, and now let's check if current timestamp is less or equal, so then our um, timestamp, which in other words is a target, then let's initialize our result with this current value. So list get mid value, and let's increase the left pointer +1. Otherwise, let's increase the right pointer. Actually, not increase, sorry, but reinitialize with a new value. And in the end, let's return the result. Okay, perfect. Now let's go back to our get method. And here we will now are able to use this binary search algorithm in order to search for correct results. So let's return. We need to call our method binary search. Inside we will send the list and the timestamp from the method arguments. And that's it. That's the solution. And now let's try to test it. So let's create somewhere here public static void main. Let's create the object of this class time store, which is equal to new store. Okay. Now let's set some values. Okay, let's copy this, I think. Here will be value 2, let's say, and timestamp, let's say 6. Okay, here will be key 2, value 1, and let it be here 3. Perfect. Now let's call our method system.out.println. Inside we call our method so yeah, get key 1 and timestamp, let it be 6. Okay, and now let's check how does it work. Okay, so it works perfect. Now let's go back and let's analyze our solution. So the time complexity is O log n. We perform a binary search over the list of timestamp associated with a specific key, where n is the number of times set was called for that key, and the space complexity is OMN. We store every key value pair and its timestamp. M is the number of unique keys and n is the average number of value per key. So the complexity looks good and we can keep it how it is. And now let's check what we have learned. So in the last 6 tasks, we looked at how to use the binary search technique. So my congratulations. I hope this exercise helped you better understand how you can use binary search, and we will see you in the next videos. Bye.